Hi everyone, let's have a quick look at topic 10.1. So in the periodic table, you're going to find the metals over here, demarked by this red staircase line. So whatever is on this side, these are metals, and whatever you have here, these are the non-metals. Right? So this is the group 1 metals, group 2 metals, group 3 metals over here. This is called the D block here. The D block metals. These are also D block metals. They fit in here. So the lanthanoids and the actinoids. And here you're going to have the transition metals. Okay, right, so this is the metals in the periodic table. Now all metals will lose electrons to form positive ions, and this is why when we have the structure of metals, you're going to have the cations in a sea of delocalized electrons. And this is the metallic lattice. So if ever you're asked to draw the metallic lattice, this is what you're expected to draw. This is for sodium metal. This is for calcium metal. And do not worry about counting the electrons. You're not expected to have the appropriate number of electrons for each cation, right? So you don't need to count. So this is one cation, this is one electron. You don't need to count them. It's just like a random number of electrons spread everywhere. And then you have the cations that are regularly aligned, and then the proper charges on the cation. This should be mentioned. This is the list of the characteristic properties of metals, and you're very familiar with these characteristics. We'll go through them quickly. So metals, these are good conductors of heat and electricity. And this is because of the presence of delocalized electrons. They are malleable, they can be hammered into different shapes, and they are ductile. Ductile means they can be drawn into wires. You need to know the definition of malleable, and you need to know the definition of ductile. Why it's malleable and ductile, it's because of the structure. You see the cations are regularly arranged. So when you apply a force, what happens is that the cations are able to slide over each other. So when you apply a force here, this layer is able to slide, so you have a different shape. Okay, right, so you see it has moved. So because of the regular lattice, because of the regular arrangement of the cations are able to slide over each other when a force is applied. They are shiny when pure and unreacted. Many of the metals will react with oxygen in air and they will form a dull layer. But when they are pure, when they are unreacted, they are usually shiny. They are sonorous. They have high densities because the cations are very closely packed, and there is strong force of attraction between the cations and the delocalized electrons, which means that there is a large amount of mass concentrated in a small volume. They also have high melting point and high boiling points. This is because of the strong electrostatic forces of attraction. And again, metals tend to lose electrons to form cations. They lose electrons because they have a small number of electrons in the outermost shell. Then it's easier or less energy is required for them to lose electrons to reach a stable octet. Then we have alloys. I'm not going to go into too much details of alloys. We've already done this part. So alloys will contain a main metal and a small amount of another element, can be a metal or non-metal. These are the three alloys. And the structure of alloy is like this. So you have these different sized element that is going to disrupt the regular lattice. So now the layers cannot slide over each other. Now an alloy is going to be stronger because you need to apply a greater force for the layers to be able to move. So because of these disruptions of due to the other element, the layers will not be able to slide right away. So you'll need to apply a larger force for you to start the movement of these layers. Then you have another question. Iron is malleable. How this property can be explained in terms of its structure. So it is malleable. Pure iron is malleable because the layers can slide over each other when a force is applied. Now, for these kinds of questions, please be very careful. Use the terms particles. Do not use the terms atoms. I've seen in some answers that students say that the atoms are regularly arranged. It's not atoms involved here. It's cations involved here. And we also have electrons. While the electrons are not regularly arranged, it's the cations, more specifically, that are regularly arranged. But we're going to use the term particles. You could also use the term cations, but please do not use the term atoms. Now, while alloys are more suitable for some uses, so alloys, these are going to be stronger, and they're also going to be rust resistant. And they can also be more aesthetic, right? So while alloys are more suitable for some uses, so it's going to be stronger, it's going to be corrosion resistant, hence it's going to last longer. You have to know that corrosion makes a metal, it damages a metal very quickly. And alloys are also more aesthetic. They look more shiny. For example, chromium is added to steel to make stainless steel. Stainless steel is more shiny and it stays shiny for a longer period of time. Hence, it's going to be more expensive and it's going to be more suitable for decorative purposes.